Okay, how about the next problem up? E is the solid generated by the cylinder. Cut off of 4, 1, 2, and let's say those are 4 each. Something like this. Y equals 0, y equals 0, z equals 0 is the floor, and y equals 2x, 2x. So to reach the side, I need x to reach 4, right? So that it hits the side. If x hits 4, then y would be 8. Oops, I missed it by a line. There we go. So we're talking about that region. So we're talking about, so the deal is get the 3D out of the way and things will simplify really quickly. The x is there. Since I could see this in terms of z, get that out of the way. If I run this with respect to z, and we're going to change that pretty soon, z runs from the floor and exits out of the top. The top is z equal the square root of 16 minus x squared. And now I'm looking at this region on the floor. This is x, this is y, and you're looking at nothing more than y equal to x, 0, 0, rise to run 1, right? So if x equal 4, because that's when I'll hit the edge of that, this is going to be 16. Now which region are they talking about? Do you see that you're running to the x-axis, so it's really this region in this case. And we know how to do this. I suppose you could say x equal 0 to x equal 4, then y would run from 0 to y equal to x. If you want to do that, of course you could do it sideways. It really makes no difference, but pretty soon we're going to do it all possible ways, all 6 different ways. I have one more example before we tackle the different combinations. How does this look? If I'm asking you to find the triple integral, here I'm looking for volume because I just put a 1 there. Well, E is the solid enclosed by the parabola. Z equal -2 plus x squared. So this opens. There you go. That's coming in. And z equal 4. Right? So those are going to hit, obviously, at a point. And wherever they hit, they're going to create a circle. Now, to get this really out of the way, and to simplify this as much as you can, I'm going to run z. Oh, I'm sorry, not z. In this case, z would be, we could do z. We're going to run x, since it's x equal or x equal, right? So we're going to run x from negative to positive. Do you see where you touch first? And do you see where you exit out of? That's very important for you to get the volume correctly. If you do that, you're looking at this from the x direction, so there's nothing left except the y and the z. In the y and the z, what you're gonna see, it looks like a circle. Now the algebra will help you, it will match. That is, if you take this and replace the x by it, take the x out of the y to see it, what is it in terms of y and z, that's really very helpful for you to confirm what you are thinking this look like. And that's going to be 4 minus y squared minus z squared equals y squared plus z squared minus 2. So if I move this to the right, that will be 2y squared plus z squared equal a 6. Divide by 2 both sides, y squared plus z squared equal a 3. So this is a circle with a radius 3. Now once you get the y in and you work that out, I suggest, it's up to you, rd theta 0 to 2 pi, because this is full, and let that run from 0 to radical 3, and you're in very good shape. Make sure you switch to r and theta as you go by and work this out. So 4 minus y squared minus z squared. Yeah. Now what happened if you look at this from the z? You're going to have to write two separate double intervals. From the y, the same deal. Two separate, one for the purple, one for... and it's going to look like this. The purple piece and the black piece look like this. So you need a triple integral for this and triple integral for that. Unless they specify, you should choose where the opening is. In which direction does the opening match? Let me move on to the next problem. And this is the whole idea. If I look at this first problem, it says, so here again, the graphing is not a must, but the visualizing is. If it says, express the triple integral over region E in 6 different ways. I'm going to look at this from the x direction, from the y direction, from the z direction. Where E is this 6 from negative 2 to 2. So, okay, something like this. Negative 2 to 4. Oops, that doesn't look like the cylinder. Actually, I could make it look nicer. There we go. I then copy that thing. There we go. Copy. Go down there and put it around negative 2. Okay, that's, I'm trying to perfect this somewhat. Of course, I grab that on GeoGebra and get it over with, but I want to make sure on a test when you look at this, you're kind of visualizing this. This is negative 2 and this is 4. So let's do the simplest case scenario. The simplest case scenario is me looking at this. From the z direction. From the z direction, I'm really running this bottom exiting out of the top. Well, that's simple. That's z equal negative 2, z equal 2. That's a plane. That's no problem. In this case, I'm looking at a circle. All what I see is a circle with a radius of 4. RD theta doesn't work because that only does it one way. So instead what I'm going to do, I'm going to say, well, let's look. If I run this, the traditional, x runs from negative 4 to 4, and y would run from y equal negative the square root of 16 minus x squared to the square root of 16 minus x squared. That's very good. Or you could have switched it. You could have said, well, no. Let y run from negative 4 to positive 4. They're not always symmetric. If this was an ellipse, that wouldn't be the case. Okay. And then x would run, come on. X would run from x equal negative the square root of 16 minus y squared to the square root of 16 minus y squared. And there it is. Now that's going to require you to use a trig substitution, which is not pleasant, but we're not going to say to solve that. We're asking for you to set it up 6 different ways. Okay. What's another way of doing this? Another way of doing this is for you to look at this, and I'm going to leave some space between them, to look at this from the direction of, let's say, x. If you look from the back, that's going to pierce the back of this cylinder. The back of this cylinder is x equal what? X equal the square root of 16 minus y squared negative, and exits out of the square root of 16 minus y squared. In that case, what are you looking at? In that case, you're looking at a rectangle. If you look far enough, this is all you see. Since you're looking in the x direction, y, z. You see z running 1, 2, 3, 4. And doesn't y run between? Okay, that looks terrible. I don't like how that looks. Let's do that a bit nicer. So we have 1, 2, 3, 4, 1, 2, 1, 2, 3, 4, 1, 2, 3, 4. We're looking at this rectangle. And remember, there's no x. This is y, this is z. And here, can't you do this? I don't need that much space because it's just a rectangle, right? Can't I say, let run from y equal negative 4 to y equal 4, and z runs from negative 2 to 2? Or the same thing, negative square root of 16 minus y squared, square root of 16 minus y squared, dx still. And can't I say no, let z run from negative 2 to 4, and y would run from negative 4 to 4. So if it's a rectangle, it's really simple, but you gotta see it. Or, what's the last case? The last case is you look at that from, so we did it from the z, we did it from the x. How about the y? Oh, I just reverse the order. Run from the negative y, and it's going to pierce right there. That is the insidemost integral with respect to y. That's y equal negative the square root of 16 minus x squared, and it's going to exit out of y equal positive the square root of 16 minus x squared for both of those. And now, what are you looking at? You're looking at this region. It's not going to be that much difference than what we just did, except there is no y. It's going to be x, z. Z still runs for negative 2, and x is going to run from negative 4 to 4. And the same deal, in this case you could say, well, let's see. Let x run from -4 to 4, and z would run from -2 to 2, because that's a rectangle. Or you could say, let z run from -2 to 4, and x would run from -2 to +2. Alright, I have one more. This one is going to be different in 3 directions. It's not going to be as simple as what we just did. Again, the hard part is visualizing what this looked like. The algebra helps you out by eliminating one of the equation or using substitution. You know exactly how that looked like. So how does this look like? This says x equal 4 minus y squared. Okay, it's in the first octave. So 1, 2, 3, 4 minus x squared. Normally, it would look like this in the 2 dimensions. So 1, 2. This should run infinitely up, right? Except you're going to cut it off by z equal 2 minus y. 1, 2. At a height of 2, you're going to cut and with a plane. So think of it as like one of those, I don't know if you've seen those. Think of that as like a piece of cake. But you're going to get a knife and you're going to cut at an angle, let's say of 45 degrees down. What would that look like? What would that do to this graph? Wouldn't this take this graph and make it look like this? No, I didn't like that. There, much better. There. Wouldn't the slice look something like that? Except that one line I don't like here. I'm going to go up to 2 units. So something like this. There we go. Okay, now how is this going to work? So let's do the simplest of them. If there is a simplest. I'm going to run this with respect to z. Z runs from the floor, and z exits out of the plane. What does the plane equal? Hey. If that's the case, what am I really looking at? If that is the case, I'm looking at the xy plane. I'm looking at the shadow on the floor. And the shadow on the floor looks like, you know what, where should I put it? Let me put it right here. And let me move this down so they line up. Here we go, perfect. So I'm looking at the shadow on the floor, and the shadow on the floor from all the way, if you go high enough, looks like there is x, 1, 2, 3, 4, y equal 2. It looks like this. And how are you going to do that? You could do that 2 different ways. So that is 0 to 2 minus y dz. I could run this and say, well, let's see. Let x run from x equals 0 to x equal 4. And y runs from 0 to y equal plus or minus, but I want the positive in this case. Square root of 4 minus x. That will take care of business for me in one direction. Or I could say, no, oops, I didn't write it. I could say, no, let's run y. Y runs from 0 to y equal 2. And x will run from 0 and exits out of 4 minus y squared. That piece is done. That's one way. Another way of looking at this, I'm going to do all 6, so it doesn't matter. I keep on forgetting to run. There we go. If I look at this, let's say from the x direction. From the x direction, I'm looking at this in the x direction. It's going to pierce from 0. And it's going to exit out of this piece right here. If I look at that piece and I try to figure out what that looked like, well, that is x equal, so what does that look like right there? Isn't that this? Isn't that x equal 4 minus y squared? And if I did that, then what am I really looking at? I'm looking at, there is no x, there is y, and there's z. Aren't you looking at this? Triangular part? And how does that work? Well, that's simple. This is really z equal 2 minus y, or if you switch them, y equal 2 minus z. So if you run this and say, well, let's run this from y equal 0 to y equal 2, y will run, z would run from 0 to z equal 2 minus y. Or you could say, nope, that's not what I want. I want it z running from 0 to 2, and y would run from 0 to y equal 2 minus z. Okay, that's another way of doing it. That's very good. That's 4 ways. 2 more to go. Or I could look at this and say, no, I want to do this. So we did z, we did x, obviously y. And how does that work? If I look at this from the y perspective, do you see, if you go far enough, what you would see running from the y direction? It would run from 0, but it would exit out of, let me think about that for a sec. Oh boy, that's gonna be the special case. That's a tough one. That's gonna look like this. Okay, no problem, we'll do that. That's gonna be, I didn't anticipate that, but it's all good. That's gonna look like a rectangle. X is gonna run to 4. Z is gonna run to 2. It's gonna enter out of the rectangle. Let me make that bigger. There's that region they're talking about, but there's a line through it. So there is a couple of ways of doing this, and they said 6 different ways. Let's just do 6 different ways. This we could do 4 ways, so let's see how that works. It's going to exit out of 0, and if I'm talking about this part, so if it exits out of that part, it will exit out of, so if it goes in the upper right corner, let me see, upper, oh, I did this backwards. This is really like this, right? This shape is going to really have a shadow right there. If you exit out of here, if you enter right there, you will exit out of the plane. So you could enter out of 0 and exit out of the plane. The plane is y equal 2 minus z, right? That means we're talking about this region. Well, this have two pieces, right? Or you could exit out of, if you aim low enough, you could exit out of the circular part. You could enter on 0. And how am I going to get that equation? Y equal, you could exit out of the square root of 4 minus x. Okay, and how does that work? Well, now, there are a couple of ways I could do this. And that's the tricky part. If I run x running from 0 to 4, then y is going to run from z is going to run from 0 to z equal, how am I going to get this equation in? I'm going to substitute what y equals. Y equals 2 minus z. Take that and put that right there. And that's going to be x equal 4 minus 2 minus z squared. And if I want to know what z equals, oh boy, so I went for the hard one first. Switch those. 2 minus z squared equal 4 minus x. Square root both sides, they're positive. And switch those. And z would equal 2 minus square root of 4 minus x. 2 minus square root of 4 minus x. That's what this is. Right? Plus 0 to 4, 0 to 2 minus z, dy, dz, dx. Z is running still from the line and exiting out of z equal to. Those two for that one piece. If you decided to go in this direction, you need two double integrals as well, right? Normally you would have to do two separate integrals for those. That wasn't intended. I didn't intend for this to be this challenging, but I just made it up. But, and again, that's not something you're going to have to do on the homework or the exam, but that's the idea. And here I could run from z equals 0 to z equal 2. Z runs from 0 to 2 as well. And x is going to run from 0 to x equal 4 minus 2 minus z squared. And then running from this and exiting out of z equal 4. Again, sorry about that. That wasn't intended, but it's a good practice to do. If I give you a choice, make sure not to choose y. I would choose z in this case. And you have something like that in the homework, but you get to choose only one direction. It's not exactly like this, but these shapes repeat. And that's pretty much it for this section.